Alright, students, welcome to chapter 10 Functions Advanced. This part, we're going to talk about limits, and I want you to listen carefully because limits show up in LCAT, not in their full calculus form, but in small, simple, and pattern based questions. Once you understand the idea behind them, every question just becomes mechanical. So let's begin. First of all, what exactly is a limit? A limit asks a very simple question. As x gets closer to a certain number, let's say a, what value does the function get closer to? So this is what is represented by this symbol. It's not asking what is the function at that point, but it's asking what is the function approaching to. A good way to visualize this would be, imagine you are walking towards a door. Even before you reach the door, you can predict what your position is going to be and you get right next to it. So, right, that's why limit predicts the value of a function as it approaches a certain point, even if the function is misbehaving or undefined at that. Now, in ANCAT, most common type of limit is substitution. I mean, if you can substitute the number directly to it. So that could be the first priority. For example, function is substitute and you have the link. All you needed was to plug in x equals to and you got the answer done. That's it. Now, whenever the function is smooth, for example, polynomials, so linear expressions, rational expressions, in all these cases, substitution works beautifully. That's your solution. Now, the real fun starts when substitution gives something like 0 over 0. And this is what we call as an indeterminate form. And when you see 0 over 0, it is you need to simplify the expression before substitution. Let's do a plastic example. Example says x approaches 4, and this is the function. Now, you can see if you plug in x equals to 4 directly, 16 minus 16, which is 0, indeterminate form. So in these cases, the simplification, the algebraic simplification comes handy. For example, you can see the formula a square minus b square equals a plus b times a minus b can be applied on the numerator. And hence, excuse me. So after this simplification, so we just shifted that into x square minus 4 square and then applied the formula. And after simplification, now you can find a definite value by substitution. But substitution worked after simplification. Hence the limit is 8. Notice we never cared about the value at x equals to 4 itself, because that value is undefined because it will make denominator equal to 0, right? And the limit only depends on what the function approaches, not necessarily what it equals to. Let's do another quick one. Similarly, the substitution does not work, and hence we apply the same formula again. A square minus b square, the golden formula for these type of simplifications. So, substitution and you get the answer. The idea is simple. Simplify the expression whenever substitution fails, and that is exactly what you'll see in at least one LGAT question, somewhere in the functions or maybe in the algebra. Now I want to show you something even simpler. Many limits appear in LCAT in disguised form that do not even need actual limit logic. They're simply asking you for the value that the expression tends toward, which is usually substitution, simplification, or factorization, not denominator no issue. For example, they just try to confuse you to that you might think that you need a formula here, a square minus b square, but there is no denominator, there's nothing, just substitute and you get 0. But you get confused, oh, how can I get 0? There must be something. No, it's not click, the answer is 0. So substitution was do it. If you get 0 over 0, not a simple 0, even if you get 1 over 0, that is equals to uh, infinity, which is an answer. It's right. Just do it. If it's 0 over 1, that is 0, that's also fine. 0 over 0 is only undefined problematic thing which you need to simplify.